Hello Mules, welcome back to my channel MuleSoft-TechZone. So this is the fourth topic on MuleSoft for advanced users. So in the previous session we have seen what is TLS and what are some terms like CA certificates or digital certificates or Cipher Suites, all those stuff. It is more kind of general explanation. So in this session, I'm going to explain about TLS and mutual TLS in MuleSoft, how to configure TLS and how to configure mutual TLS. By the way, what is mutual TLS in MuleSoft? So without wasting time, let's get started. So let's take a recap of what we have discussed in the previous video. So as I said, like we have seen what is the role of TLS, what is the role of CA, why we need to use TLS, and at the end of the session we have discussed about keystores and test stores. So in short, key stores are nothing but it stores the keys and certificates of its own application. That means if you consider client as our application itself and server as the end user, so Keystore basically stores the keys and certificates of its own application. That means it has client certificates, whereas Truststore stores the certificates of server to authenticate. So this is in short. So Truststore has the certificates of the client, Keystore has the certificates of its own. So things to know about TLS config in MuleSoft. If at all, there is an important note that TLS 1.0 is no longer a valid protocol due to its vulnerabilities. So basically you need to use TLS 1.1 or 1.2 versions. So how to remove TLS 1.0 is you have to edit this TLS default.config or TLS FIPS 140-2.config and remove TLS v1 from the enable protocols field. So if you go to the Anypoint Studio, you can find this particular Anypoint Studio folder where you have installed. You will be seeing these two files or one file. So basically you need to remove this TLS 1.0 from the enable protocols field. And how to edit your runtimes TLS configuration file from Studio. So go to the installed Anypoint Studio folder. Within that you will find the plugins folder, and you can find inside another folder org.mule.tooling.server whatever runtime it is, as you can see on my screen, and go to this particular root folder and you can find this TLS default.config. Likewise, you can edit your API gateways TLS configuration file from Studio going to this particular server. So you can see the paths of both runtimes and API gateways. So you have to edit this. Next, if you have apps, the applications built within Mule runtime 3.9 or later, and you use JDK 1.7, then TLS 1.2 is not supported. Okay, it is important or recommended that you have to update your JDK to 1.8 version to support this security protocol. So if you want to enable TLS 1.2, JDK 1.7 is not supported. And if by any reason you can't update your JDK to 1.8, the only way is you have to manually configure Mule 3.9 to point to the TLS v1.0 version. So these are the few things that I would like you to consider before getting started, and these are the things that you need to know as an advanced user. So a very basic question that you might be getting in exam, or it's a generally interview question: what if you give TLS config as none? You know that when we are connecting to an external system through HTTP requester, and if it is a HTTPS protocol, as you can see on the screen, the protocol is HTTPS, but still you are giving TLS configuration as none. So what will happen, right? What if the target API that you want to consume has this HTTPS protocol using HTTP request and the TLS config is set to none? Well, there are two scenarios. One, it fails. Okay, if the TLS config is set to none, that means the HTTP request configuration, the communication between the MuleSoft application, which is your own application, and the target API will not be secured using TLS. Okay, and even if the certificate of the target API is signed by a trusted certificate authority like CA, the lack of TLS encryption, that means when you're keeping as none, it doesn't have TLS encryption. That means the data is exchanged between MuleSoft and the API that can be intercepted, and it can be read by any third party entity. who has this access to your network. So basically, if you are setting this configuration to none and enabling HTTPS protocol, then the application will fail. It won't be able to connect. Okay. And yep, but what is the next step? You have to enable this TLS and configure it properly with the appropriate certificates, and you can establish a secure connection among the channel and ensure the confidentiality and integrity of the data being transmitted. So this is scenario 1, when you are not, basically when you are setting this TLS to none. But there is another way with the same configuration, which means setting the HTTPS protocol with TLS none, it will give success. But how? We saw in some cases, or in our real-time projects, sometimes even if the protocol is HTTPS and TLS is none, it works. Why? Because if this particular CA certificate is present in your GRE's default Keystore or Truststore, it means that CA's certificate is trusted by the GRE, okay, Java Runtime Engine. So this allows the GRE to establish a secure connection with the target API that presents a certificate signed by the trusted CA. Well, so when a client, like such as MuleSoft, connects to a, when I say client, our application, okay, when our MuleSoft application connects to an API using TLS, it verifies the authenticity of the server certificate. If the server certificate is signed by a CA that is trusted by client, in this case the client is JRE, and the connection is considered as secured and trusted. So having this CA certificate in JRE's default Keystore or Truststore provides a level of assurance that server certificate is valid. So to give a successful response without TLS configuration, you would need to have these CA certificates in your JRE's Truststore. It's not in Keystore, because I have already mentioned that Keystore is the place where you store your own certificates, but here we are verifying the identity of the server. So the server certificates has to be there inside your JRE Truststore, right? So generally the JRE Truststore contains a list of the trusted CA certificates. And as I said before, the key store in the JRE is used for storing private keys and certificates that are used by application itself to present its own identity to other parties. So it is not directly related to trusting the server certificate. So in this scenario, if you are using HTTP requester, very simple, using HTTP requester with HTTPS protocol with TLS none, you have to make sure that your the server CA certificates has to be present in the Java Runtimes Engine's Truststore. All right. And there is a need where we were asked to convert this JKS Keystore into PKC S12 format, which widely called as PFX, right? So what is the reason behind that? So basically the PKC S12, which is also known as PFX, is a widely supported keystore format that is used by many systems, applications or tools. So by converting the JKS keystore to PFX, it ensures the compatibility and interoperability when working with the systems. So it is always good to convert JKS keystore into PFX format so that it is widely accepted. And we can use Keytool command to convert this particular JKS keystore to PKC. So when I have given this exam for MCD level 2, I remember that they asked this question, how to convert your JKS keystore to PKC or PFX. So it is quite tricky because all four options look similar. So very easy way to understand. That's why I use different colors here. You can see the Keytool command, which is common, and first you are using hyphen import keystore. So basically you are importing the keystore, and hyphen source keystore, the place where you have your keystore, and your keystore.jks. Basically we are converting. The question is to convert JKS to PKC. So that means first your source should have the JKS and the destination should have the PFX, which is .p12. PKC S12, if you want to know the extension, it is .p12. Okay, so basically the source will have the JKS certificate and the destination will be having the PFX certificate. And this is the Keytool command, where in this command you can replace your your jks your keystore.jks with the file name and path of your jks keystore that you want to convert, and also you have to replace this keystore.p12 with the desired file name. Okay, you want to name it with your desired name and the path for resulting the pfx keystore. So once you enter this command, what it will say is it will be asked you to prompt to enter the passwords for the source of the keystore and the destination. Make sure to provide the correct passwords when prompted. Okay, this is how you can remember the conversion of jks to pfx or pkcs12. And after executing this command, the jks store keystore will be converted to pfx format with the specified file name and the path given in the command. Next, this, if you look at this screenshot, in many of your applications probably you might be seeing this option, or you might have used this option in the real time. So what if you are enabling insecure option in the TLS config of HTTP listener? This is this particular configuration I'm talking about HTTP listener. That means when you create raml and when you generate the flows, the HTTP in the main raml, you will be seeing HTTP listener, right? If you go to the TLS section, if you are using this insecure option, what will happen? So when the insecure option is enabled, that means you are saying that TLS encryption and authentication mechanisms should not be enforced. Okay, basically insecure means you are not allowing this to be encrypted, which means that the communication between the MuleSoft application and the clients will occur over HTTP protocol. Okay, without any encryption or verification of the server's identity. So what will happen if you are enabling this insecure option? What will happen is this HTTP listener accepts all kind of requests which are not basically authenticated. So basically in the previous section, in the previous tutorial, in the topic 3, we discussed like TLS is more of using a secured way of transmitting the data from client and server. What if it is not secured? We already discussed that attackers might be able to view your information that you are sending from client to server. So that's the reason basically we are using TLS. So in this case, if you are using insecure option, that means anyone can send the request and your listener will be accepting without accepting the requests which are not authenticated. So this is also very important to know whenever you are working during the interviews, or even in the examination point of view. So, and as the title shows, what is mTLS? This is very simple. mTLS means mutual TLS. In the previous section, we have seen like sometimes when we are enabling TLS configuration, we usually sometimes configure only Keystore, right? And sometimes we configure only Truststore. Any one of them, sometimes it works, right? It's not that two keystores and truststores are not mandatory. But mTLS is nothing but mutual TLS. That means in simple words, it clearly requires both keystore and truststore configuration is required. Okay. So mTLS, as I said, mutual transport layer security authentication. There is no mTLS word as such in the configuration, but it's simple, like it's authentication is a security. It's a kind of security mechanism that ensures both client and server in a communication exchange can verify each other's identities. Okay, it is just like adding an extra layer of protection, which means it gives more strength for the encryption. It's not that TLS is not secured, TLS is also secured, but this particular mTLS gives an extra layer of protection. So what it does, it requires both parties, which means client and server, to present their digital certificates to establish the trust before any sensitive information is shared. In TLS configuration, what we have seen is client will send hello message to the server, and server responds back with a hello message along with server's digital certificate. But here in the TLS, we never saw that client is sending its digital certificate. However, in mTLS, both client and server has to share their digital certificates for more encryption, for better protection. So imagine, for example, in a layman's term, you are attending to a top secret meeting and you need to provide your identity to enter. So what we will do at the entrance, which means client, shows your ID card to the security personnel, and they will also show their identification. Okay, so they as in server. So you show your ID card to the security personnel, and security personnel show their identity card to you. In this way, if both parties identities match and are verified, probably you both might be having some code to identify each other, you are allowed inside. So that's how it works. So during the mTLS handshake between a client and server, the Cipher Suite here, the Cipher Suite exchange is the process where both client and server, they negotiate and agree upon a mutual supported Cipher Suite for securing the connection. If you remember in our previous session, cipher means it is an algorithm for encryption. So now, which means negotiating and agreeing upon mutual supported cipher suite means during the cipher suite exchange, the client and server negotiate and agree on a common encryption algorithm that will be used to secure the communication. The encryption algorithms defines how the data will be encrypted and decrypted and ensuring the confidentiality. So this is also very important to know. That's the reason sometimes in mTLS, when I say mTLS, both Keystore and Truststore, sometimes we define the cipher suites, where both parties agree on a common algorithm. Well, how does this mTLS process happens? We have seen TLS handshake, but let's see how mTLS handshake happens. So first thing is client authentication. So when a client or our application wants to communicate with a server, it presents its digital certificate as proof of identity, and this certificate will be issued by CA authority and contains the information about the client. Second thing, server authentication. The server in return presents its own digital certificate to the client. The client verifies the server's identity, which is also issued by the CA. So what happens in the third step? Both client and server independently verify their authenticity and trustworthiness of each other's digital certificates, and this involves checking if the certificates are valid or if they are not expired and if they are issued by the CA. Finally, once both parties have verified each other's identity, they establish a secure connection using a TLS encryption. So this ensures that all data transmitted between client and server remains confidential and protected from unauthorized access. So very small difference, it's like between TLS and mTLS. TLS, only server is sending the digital certificate, whereas in mTLS both client and server both exchange the digital certificate. So how to enable mTLS process in the HTTP listener? As I said, there is no mTLS configuration here. Basically, you can see in the XML configuration here, you can see TLS client, Keystore and Truststore values are configured here. So as the definition of mTLS is quite evident, it requires both appropriate configuration of Keystore and Truststore config in the HTTP listener. So if someone asks you like how to enable mTLS, then you have to say like, if you provide your proper configuration of both Keystore and Truststore, then mTLS is enabled. So last but not least, so how to create a Keystore or Truststore? What is the command that is being used to do that? I have already created one video on this. If you can go to YouTube on MuleSoft-TechZone, this is a separate video that I have made, like how to build HTTPS service in a simple way. In that particular video, you can see how you can create Keystore and Truststore. Okay, so this is all about, so topic 3 and topic 4 is all about TLS configuration and mTLS, and how these are configured inside a HTTP requester or HTTP listener. So you will get quite a few questions, probably for 3 to 5 questions in MCD level 2 exam about it's more kind of a general information. You need to know what is the role of what are the roles of TLS or mTLS, or what happens between the handshake process, what is a client, what is a server. So if you understand things in an easier way, it helps you to remember things, right? So client is, consider client is us, server is the third party, and very simple. Client, so if it is a TLS, client won't send any digital certificate, but server will send the digital certificate which will be verified by the client, that is TLS. In mTLS, both of them exchange the digital certificates. Not only that, you have to understand the difference between Keystore and Truststore. So Keystore is the place where we store the private keys and the certificates of our own applications or client itself, whereas Truststore is the place where you have the certificates of the server. When server is sending in TLS configuration or in the TLS process, handshake process, server is sending the certificates. So you have to store the certificates in some place. That some place is called as Truststore. All right. So yeah, well, if you go through this video carefully and if you understand the concept, I think you will be answering questions both in interviews and in the examination. See you in the next session.